All right. Thanks for having me here. It's been exciting to be part of this. How many of you have been to the Harry Potter ride in Universal Studios? Many of you here. So if you get on that ride, you go through suddenly, especially being a Harry Potter fan, you go through this where suddenly there's mysterious creatures come at you, there's dragons and dementors scaring you, but then it's all exciting. And then you go up on stage, you see Hogwarts from the top, you go into the dungeons. Man, it never ends. It feels like you are like experiencing something magical, thrilling. That's how I feel every day being in AI, right? It's pretty amazing how many things are happening. But by the way, before I got on this ride, I was an operator. I was CTO of Atlassian. I was on a normal roller coaster ride. I built systems at Atlassian, full stack, built out cloud, 0 to 2 billion revenue, lots of exciting things. But here's the thing. These days, different aspects of the stack come back and talk to me on this ride because they keep telling me, wow, AI is going to change me. It's so exciting. And one of the things, the beauty is I get to work with such amazing companies and invest in AI. I focus mainly on AI as a VC. And I get to work with Lucas and Weights and Biases team, which is pretty amazing in terms of the experience. All right, with that, what I want to do is to spend time today on three things. First is, what's happened in 23 and how are we going into 24? Next is, how is that happening? And then lastly, we'll cover on a trend that's super exciting for all of us. All right. To ground us all, we are really early in this AI revolution. Right? If you see the previous evolution, S-curves, the slope of the S-curve is increasing, which means that AI is going to ride faster on these waves, but we are still very early in the process. There's massive developer excitement. Seeing all of you, I can sense that. And this only shows one part of it. We see it in, we have a lot of data that we look at, and we see it across every single data set. And you look at this graph where the adoption continues to increase. And take an example of Replit. Replit has more than 4 million developers using AI. That's 50% of all developers on it leveraging it. I'm assuming all of you are using Copilots because in every survey that we do, in every interactions that we have, it clearly improves productivity at least by 50%, if not more. Right? So that's pretty amazing in terms of AI is adding value today. It's not like in the future. And the graphs that you see are pretty robust in terms of growing up. Literally every curve. These are good curves to see in terms of developers and users going up onto the right. That's developers. If you look at enterprises, enterprises are also deploying AI, and they have plans to deploy AI in 2024. This is across IT, customer support, and in finance. And every CEO, the way it happened was you look at the last year, and every board asked for an AI strategy. Every executive team started scrambling around to build the AI strategy. And they all have plans to build it. Most of them are in proof of concept stage. The penetration into enterprises are less than 10% for the very first use case, which means there's a lot of room to be able to deploy things. One of the things that has happened, which may be familiar to you, is as soon as you start the AI project, the first thing you do is build out your data engineering piece. Right? Get it into your data lake, get your data in the right place. And that's what is happening, I guess, right now, but we will see a lot more deployments this year and continued increase in terms of just the data that we are seeing and what we project going forward. Internally, we also have a pretty large AI system. We have 30 engineers working at Coatue. The good part for us is we have been working on the data lake for the last 10 years. And that has really helped us to be able to kickstart our Coatue Brain project. And we have built out different modules and pieces to be able to have a real system that adds value to our company as of right now. So everyone at Coatue uses different aspects of it, different use cases, depending on whether we are trying to find companies, trying to figure out what stocks to invest in, different use cases to make us more optimal and efficient. We have a number of use cases. And one of the things that's happening in this developer ecosystem is there's lots of building blocks coming into place. Right? There's vector databases. There's frameworks that you use to be able to llama index and weights and biases and tools and things like that. So every single block has a number of products that are becoming a lot more easier to use, easier to deploy, which is helping people to get into production. So you'll start seeing a lot more deployments from enterprises across the board. Second is a very important aspect of why AI is succeeding. And AI is succeeding because it's built in the open. What I mean by open is open research, open community, where conferences like this, people interact and exchange ideas, models and data, and open tooling. So we'll go through different aspects of this in this slide deck. All right, let's start with open research. It used to be that only universities did open research in the past. And what has changed in the last year is even the large companies are publishing lots of papers, especially in AI. And it all started with attention is all you need. And as you know, every big model that comes in, there's also a paper associated with how it's being built, which helps everybody else to follow pretty quickly. And that has given rise to a pretty accelerated models being released. Today's mysterious animal is llama. Llama 3 is creating buzz, but I'm not kidding. Every few days there is a really big milestone that's happening in AI, and that's adding up to the overall innovation across the board. So the velocity is actually not just constant, but it's increasing, it's accelerating. If you look at the number of contributions that's happening in this, it's increasing. This is a good trend in terms of constant growth, in terms of number of commits into public GitHub. Models increasing on Hugging Face. This looks really good and keeps going up. It's even bigger now. When we talk about open in AI, it's not the same as what it was in cloud. So you need to break it down into different dimensions. There is code, weights, training data, evaluations, how you build the architecture, and also the licenses. You'll start seeing towards the end that there's one thing that's not open. Most of the open ones are open except the training data. And that's for two reasons. One is data is the new secret sauce for all these companies. And second is it's actually liability to put out their data because it calls for attention that companies don't need. But when you're looking at open models, you need to also think about all the different dimensions of open and what it makes sense for you when you use it. And the beauty here is the open models are actually at the tail of the large models, the best models. And if you had asked me last year, I would have said open models are 12 months behind the closed models. Today, that window is shrinking, right? That distance is shrinking. It's probably 6 to 9 months. And that's an exciting trend just to accelerate overall ecosystem in AI. And we have also done surveys where we know that enterprises are going to use, are already using open LLMs in their production, mainly because also they can run it in their own VPCs and such. But they're going to increase using this going forward. And the other trend that's also very interesting that wasn't the case in cloud is multi-sourcing. Like every deployment of AI is not just using one model, it's actually using multiple types of models and models from different sources. And this is exciting because you may have a large model that can do everything, but that's not how it's being deployed. Then you can break it down into smaller tasks and use smaller models, different sized models, different types of models specific for their tasks. So that's definitely a trend that we are seeing. And we also asked why you're using multiple models, and there are different reasons that they're using right now, but that will evolve as the ecosystem matures. Now let's cover the last piece, which is you've all seen the Copilot, so how is that evolving and where are we headed in that? This graph here shows one of our portfolio companies. It's a fintech company. They deployed a customer support AI model. And what it shows here is on the leftmost bar chart, it's the AI model agent is cheaper, which you would expect, because it's not a human, they're not paying for it, only runs when you have to. It's faster, which you would expect. Because it's AI, it's much faster in terms of responding to queries. But the last one is actually the most surprising part. The CSAT score for this customer agent is better than the average for humans, which you might say, oh, wow, they've actually improved it better. But even more interesting fact is it's actually better than the best human on the team. Right? The best human had 67, and I think it has 69 in terms of customers' CSAT score. And that, I think, already proves that with the current technology that exists with copilots, it's already adding value and can do a lot. And one of the trends that's happening in this, as we zoom out and look at how different products are adding AI into it, we are starting to see this new layer getting formed, and this is an evolution of what has happened in AI or in technology before. We used to have infrastructure as a service, then move to platform as a service, then software as a service. And now what's coming is an intelligence as a service. And this layer is extremely important because then it allows you to innovate on much more interesting use cases that we could never do before. And the reason it's also important is because it becomes a reasoning engine, a logic engine, which can reason just like humans, right? And the other trend that's happening, and the reason why it is improving in quality, is companies are spending more on training these models. And GPT-4 was about 100 million. And we have this crazy number of 1 billion. But it's actually, if you think about it, it's not as crazy, right? How much would a company pay to create an AI that can do pretty much all human-like reasoning tasks, right? You would spend that easily as a large company. But also, if you look at it, most of the training was done using this, or they would stop at this, what's called the chinchilla point, in terms of what's the optimal point to be able to run on the GPUs and to be able for compute. But today's Llama 3 is actually an example where they went way beyond that point, in fact, 75 times more, and actually improved, which means if you train longer, even with the same data sets and with more tokens, it's going to get better, which means you will see a lot more companies training and spending a lot more on these models. So here, the x-axis here is a evolution of, we start with on the leftmost side as a copilot, which means that's what you see today, ChatGPT, and you ask a question, it comes back and tells you an answer. As you move towards the right, and there's a number of examples, lots of products that are coming in as copilots. In fact, every product is adding a copilot. But we are also starting to see signs of what does it mean to move right. At some point in the middle, that flips into AI does things, and it comes back and asks humans to be able to help it out. And if you move all the way to the right, that's the future. That's not imminent this year, but if you go all the way to the right, then it goes into the autopilot mode. And on the y-axis, there's a number of use cases that you need accuracy in terms of it, and some that needs creativity. I didn't call it hallucination, because some people say hallucination is bad, but it's actually really great for some use cases. Like, for example, marketing, you want to write a creative material, you want to hallucinate. And we have seen the same kind of evolution before. How many of you remember the day when this chess match, famous chess match between IBM Deep Blue and Kasparov happened in '97? I was there, I was a chess fan. It's fascinating how it was a 6-part game. And in fact, in one of the games earlier, not the last one where he lost, but in one of the earlier ones, computer made this move where Kasparov was taken aback saying, whoa, this can't be a computer. So he actually started an investigation saying there must be a human playing it on the other side, which is how we feel when ChatGPT gives us an answer saying, whoa, this can't be, how did it know this? But what happened, he lost the game. And then what happened for the next 10 years, there was this period where humans paired up with a computer always beat the computer. So Kasparov famously said, that's the future, that's how it should be, because humans and computers need to work together. But that stopped after 10 years. And then computers would beat any combination. So what does this mean for us? So we are in the early stages of agents. And agents, like there's been a number of examples. You probably have seen Devin and this number of software agents. Let's take software code creation. It does some simple use cases, but it's not all the way there yet. But it's trending towards that direction. There will be a point in the future, just like how it happened in chess, where that agent does not want you to intervene because your input is not as useful, and it's only going to hurt the final output. We'll get there someday. All right, and the agent mechanism is actually proven to be much better than just making one call. This is a survey that we did, a research that we did, where our research paper graph, where when you have an agentic mechanism, that's significantly better than just making a single call. There's this famous book called Thinking Slow and Fast, Thinking Fast and Slow from Daniel Kahneman, where he talks about system 1 and system 2 approaches, where system 1 is reflex, super fast, you're not thinking hard. If you have to catch something, then you automatically reflexively catch. That's system 1. System 2 is where you deliberately think through hard and make some decision. LLMs don't have that today. Right? An agent is one mechanism where you induce a system 2 approach, which is how it gets much better. But assuming that comes in with infinite memory and personalization, there's a lot of improvements that will come in as agents evolve. And all the things that I've talked to you right now is all about digital world. And now take that same thing, what happens if you take it to the physical world, right? If you thought starting where we were on a roller coaster was already crazy, this is a roller coaster on a roller coaster where your robots are creating chaos next to you. But it's a bit different, and it's also a little bit harder than what we have had so far. Because the reason it's different is, and I've spent the last 2 months just digging into robotics across the board, and the reason it's different, LLMs had this advantage of having the internet for you with all the data, and you could train based on the internet. For robotic AI, that's not the case. So you'll have to, as a first step, you have to generate these data sets. Because for robots, you actually need to have the action also captured as part of the data set, which doesn't exist. So there are a number of approaches that people are using. There's teleoperations. Aloha was a project from Stanford that's doing extremely well in terms of demonstrating what teleoperations is. Then there's also a number of simulation software where you use simulation to generate data, because it also has physics, and use that to train a model. And there's examples of smaller models, RT1 and RT2, that's already built, that shows the proof of concept of what can be built and what can be taught in terms of these models. But as you saw, this adds another dimension to all the things that we are planning to see. And if we thought the AI wave was big, this is going to be even bigger. But again, I just want to lay it out on specific 3 points that we had. But I hope you're also as excited as I am. But that's all I had for today. There's a lot more we could talk on robotics, but find me afterwards. But thanks for having me here.